Hey everybody, it's me, Steve. It is April 12th, 2018, times like 17:15. Now, I promised you that I was going to make a video about our lunar observations on Easter weekend, but we had some problems. I will link below the video where I did the two-scale model of the Earth-Moon system to make these predictions. I will link that one below. It's long. Hopefully this won't be. But the problems that we had was weather, as usual. We did get some cool looking pictures, though. But anyway, here, what you see here is the moon calculator for the night of March 31st, 2018. And my prediction was supposed to be from the night of the 30th to the 31st. But the observation I made was on the night of the 31st to the 1st, because it was so funny because we get up there and we have clear skies, but we got up there late. We see the moon rising above the horizon. We're like, oh, we'll get more observations later. And then like an hour later, the clouds move in and then the snowstorm comes. But anyway, this is just the moon calculator. I didn't look at this until I prepared this presentation, but here you see three arrows. You see the time, the green arrow is the time of the photo. I'm going to show you only one observation turned out. All right. The white one is moonrise for that night. The red arrow is showing the altitude of the moon at the time of the photo, and I had predicted 20 to 25 degrees, but that was for the previous night. All right. So I predicted the altitude and the night to which my scale Earth Moon models. So I was close to the actual 27 and a half. That was predicted for the night before. But anyway, I just wanted to show you that, just to show you that right there. Okay, so Sarah actually took the photo. This is the only usable photo that we got. The information's on the left. You're going to see it there. All right, so what we got to do in order to see if our prediction matched at least this observation, this would have been equivalent to observation number 2 in my model. Remember, observation number 1 was totally unusable, so we actually did try to get an observation 1, but the clouds are right at the horizon. The pictures at the end of this video are of the moon rising on that night, and then at the very end will be the math I did to do this, if you're even interested. Most people aren't. So my predicted angle based on my model was 30.4 degrees. My predicted angle with maximum margin of error was 33.4. Now remember, using Tycho crater as our reference. It's that yellow circle. But as you can see, even with the predicted maximum margin of error, I was off. All right? By a lot, not just within a margin of error. The observed angle was actually 41.5 degrees, that red line there from the yellow vertical line. All right? That's an 8.1 degree difference outside my maximum predicted error of 33.4 degrees. So we go to Dial-A-Moon, sorry, this is from Dial-A-Moon, and the slide where I took this from will be at the very end as well. And to see if Tycho had changed orientation in the sky from the night of the 30th to the 31st due to librations. So that's what this is showing. And as you can see here, it didn't really change much. I predicted a 5 degree tilt to the right of Tycho crater from the center line up and down, and the next night it was only 5.5 degrees. So libration can't really account for me being outside my extended error. So what could have account for the extended error? Well, maybe my model was off. That's one possibility. I mean, to some degree, something could have not have added up. I mean, with all the checks and all these angles going on, that's a good possibility. Two, the tripod wasn't perfectly level. But Sarah's tripod for her camera has 2 bubble levels, unlike my cheap tripod, which only has 1 bubble level. So that probably wasn't it. Or 3, I simply overlooked something. There was something I overlooked. Can I know for sure what went wrong? No, not really, because we only have 1 data point. But I do have a strong suspicion, because remember, I was going to make 5 observations, but I only got 1. So I don't really have enough data. So what could have gone wrong? It's looking like the model was off, right? Now, this is observation number 2, take 2 from the video that's linked below. And you can see there's an angle of tilt here of 25 degrees, which gave me my prediction of 22 degrees with my margin of error of plus or minus 5, which would have been at 27 degrees. My moon was looking at it like as if I was looking at the disk of the moon in the sky. That seems to have been correct. What was incorrect was the tilt. It was not 25 degrees. It was more like 36 degrees is where it should have been. Now, if you remember when I was doing that, I had the camera tilted, but I was using rocks to support the camera. There was no way for me to really hold it and do this and rotate things and do all that. I only have 2 hands. So somewhere in the process, that 36 degrees dropped more than 10 degrees, and stuff happens. But how do I know that's it? Well, like I said, I can't know for sure, but I can have a strong suspicion. Well, this is why. If I would have had the proper tilt of the 36 degrees, actual calculated tilt is 36.28, I would have been nearly dead on. With 36.28 degrees plus the relative tilt of Tycho crater at 5.5 degrees, I get 41.78 degrees, or approximately 42 degrees. The observed angle is 41.5. So I failed. But the important thing to take from this is that even in our failures, we learn something from that. It's okay to fail. It's okay to make an error. We're human. We all do this. But you have to be able to learn from it. You can't sit there and say, well, my observation didn't match reality. What's wrong with reality? That's not what you do. You have to have the ability to question yourself and your own calculations, your own setups, your own predictions, all that stuff. If you do not have the ability to do that, you are not seeking empirical evidence. You're just fitting a preconceived notion. But anyway, if you take anything from it, take that from it. And anyway, please like and subscribe, and I hope you all learn something.